go through it. So yesterday we set this one up. And I kind of gave you guys this chart. And the chart here led you into your inequalities. It was 5, 4, and 155. If you have not tried this yet, if you set up a chart about the different things you're looking at, sometimes it helps you to figure out what in the world you're talking about. Now in this case, we have to maximize profit. And I know that the breakfast bar plus the granola bar is what I want to do for my maximizing profit. I make 40 bucks on this one and 55 on the other. Now the two different parameters that you're looking at when you're solving this one out is that you have 150 maximum machine hours and 155 maximum labor hours. For each of these, it depends upon breakfast and granola. So you've got 2 breakfast plus 6 granola for no more than 150 hours. 5 breakfast, 4 granola, bless you, no more than 155. Can I have negative breakfast bars, granola bars? No. No. Okay? So that has to hold true. Now, from here, it's just a matter of plotting, covering, and solving. So, one suggestion. 2, 6, and 150. What can you say?
First 2, 6, and they're divisible. 150 is divisible by 2 and 6. In a way.
What if I just wrote as this? B plus 3G. Is that okay?
Right, yeah, that's what I meant.
Is that okay to do that?
Yep.
What I'm doing here is, they were all divisible by 2. It just helps, I mean, when you go to plot your intercepts, you're going to get that anyway. It's not going to change. What helps by doing it this way is that when we try to find the intersection, it sets you up for a substitution. It's a little bit easier than trying to do a linear combination. Okay. So now we know, let's see, we have B, G. Cover and solve, I have 75 and 38 and change. Here's my list here. Yeah. That way I remember which ones I was doing where. So many of these things are maybe I'll look a little bit. Right page. One of these pages. I don't really know what it was. Oh, there it is. What page is it? There you go. 75 and 25. Working in, working. The other one we have intercepts at 31 and 38 and change. Those 2 points intersect here. You do get this bounded region in there. So you have to figure out where those 2 lines intersect to get your 4 different ordered pairs. Now, by setting this one up right away as B plus 3G, I can say that B is 75 minus 3G. Do you agree?
Yes, sir.
Remember if I hit this board or not. So that means B is 75 minus 3G. Substitute in the second equation, or excuse me, the first one, we have, no, it is second, 5 times 75 minus 3G plus 4G is 155. Oh, you work everything out, you get 375 minus 11. G is 155. Negative 15 plus 4. Moving things around, you wind up with G equal to 20. Okay? So the intercept here is something comma 20. In order to solve for that something, well, Substitute back in. 3 times 20 is 60.
Uh-huh.
75 minus 60 is?
15, sir.
So there's my 4 ordered pairs to work with. 4 ordered pairs are 0, 0, 31, 0, 15, 20, and 0, 25. When you work all that out, I do believe you wind up with 15, 20 being your maximum. Okay? Remember, to get the ordered pairs is when you solve the system of equations. Some form, some way, whether it's using substitution or it's using linear combination method to solve for those two intersect. That's how we set those up to find that other ordered pair. All right?
What was the maximum?
I believe it was 15 and 20, if I'm not mistaken. Okay. I am going to do the farmer one first, because that one is easier than the machine one. If that's okay.
No, I thought that one was harder.
Farmer one?
Maybe
Do you want me to do the machine? Which one do you want me to do first?
I just didn't understand.
I'll do farmer one. I'll do farmer one.
I didn't get it.
The farmer one is very similar to this one. You only wind up with 4 points. The machine one's weird because you have to make an extra equation. You wind up with 6 things to worry about instead of just 4. So let's look at the farmer one. As you read through the whole problem about the farmer, and it's funny, last hour we had a student tell me that her dad does farming, and she said, that's not right. And it was pretty funny.
Is it Heather?
No. Basically, she said there's no way you could get $6 for an acre of corn. It's like $500 for an acre of corn. So she went through all that. It was pretty funny. Her dad made her rework the problem with real numbers. I was like, that's the greatest parent ever. So in this case here, when you read through the entire problem, at the very end, it's stating that it wants you to maximize your profits. Okay, at the very end of the problem, it says maximize your profits. So you have to figure out, well, what are your profits for corn and for beans? So you make $24 for the corn and $48 for the beans, and that's going to be your objective. After that, you go back into the problem, and it talks about how much things cost and how much storage space you need.
Yeah.
Because I read the problem. The farmer earns a profit of $24 for each acre of corn and $48 for each acre of beans.
I thought you had to do letter A before you did letter C.
I'm just reading through the entire problem. Okay. Remember, this was taken from a book from the mid-'80s, so the way it's written out was just a little bit different, but you still set it up the same way.
That's why it's different.
Okay. Now from here, you had money to deal with and storage space. The money, it was $6 for corn plus $12 for beans, and you had no more than $2,400 to spend. Storage space was $12 for corn, $16 for the beans, and you had no more than $3,600 as far as your space was concerned. Can you have negative values? Corn greater than or equal to 0, beans greater than or equal to 0.
Mr. Murphy?
Yeah.
This I'm good. Like I see it and I'm writing it down, but when I'm on my own, I'm kind of like, what is
This, remember, it was the first day you've ever tried this. All right? And I told you guys, it's going to take 2-3 days to get through this whole thing.
Yeah, for sure.
And it's not a big deal. We're going to do another day of this today, and I think we'll probably just do a little bit more of it tomorrow as well. By this time tomorrow, it shouldn't be an issue. I'm not lying to you. Yes, sir?
Is it going to get harder?
No.
And you're just going to kind of throw problems at us?
Yes. Okay. Now we go into our graph. We are first quadrant. Oh, before I do the graph, look at these two equations real quick.
Yes, sir.
Can I simplify them?
Oh, yes, divide by 6.
Divide by 6, so I get C plus 2B is 400. And then on the next one, I'm going to divide them off by 4. I get 3C, 4B, 900.
Wait a second, sir. Is that 166? Or is that 100? Or is that 16B?
16B.
Divided by 6?
4.
Oh.
First equation, divide everything by 6. Second equation, divide everything by 4. The only reason why I did that is because I'm going to have to do it anyway when I find my intercepts when I cover and solve. I'm just getting the least common multiple out of there. That's all. It just makes it a little bit quicker. Plus, now you see how I'm setting it up to use substitution that way? I can get C by itself in that first equation to substitute in the second to solve for it. Cover and solve, we got 400 and 200. I'm going to call this one C, this one B. 400 is about here. 200 would be about here. Inward or outward? Inward. The next one, I'm at 300 and 150? 225, excuse me. 225 and 300. Also inward, means I have to figure out that spot. So I'm at a 4-sided figure again. I can say that C is 400 minus 2B from here. So 3 times 400 minus 2B plus 4B is 900. All I did was use substitution there. 1200 minus 6B plus 4B is 900. Moving things around real quick, you get 300 is 2B, not 2B.
I just said
You're funny.
That's what English is good for, humor.
only they can talk
Oh, Beverly's a good golfer too.
Are you a good golfer, Mr. Murphy?
A lot better than Severino.
That's a good.
So now I know what the value of B is. To figure out what the value of C is, we know that it's going to be something comma 150. What's 2 times 150?
500.
400 minus 300 is?
100.
So there's your 4 ordered pairs to check. 0, 0. I'm going to go out on a limb and say you're not going to make any money if you don't plant anything.
I'd say that's okay. So did you get 150?
300, 0.
Let's get rid of them.
100,
You know how you sell, how you
150,
make money with it?
and 0, 200.
So wait, who is this?
You have a circus on it.
Kid in the 3rd hour. Now in this case here, when you substitute everything in, you solve it out, you wind up with 2 maximum values. You get a maximum value here and here at $9,600. That's what they call an anomaly. It can occur in these style, he gets it.
Yeah.
It can occur in this style problem that it is possible that you could get more than 1 maximum. It is completely possible. And that's just dependent upon the parameters of the problem. It won't happen all the time, but every once in a while you will see that it does occur.
But that,
Daisy, what do you got? The main equation was that I got that $24, I was earning 24 bucks for corn and $48 per bean.
you were shading.
No, he's talking about like
I'll bet you guys go. What?
That's all. Somewhere along the way. All right. Now, the last one, when we get into the machine one. To be honest with you, the machine one is the most difficult one that we have. We do have a problem somewhat similar to that tonight. So this is a good learning curve to make sure that we're ready for it. To be honest with you, I don't know. I haven't written the test. Now, let's take a look at how this one works. Come on, guys. Yes, sir. Next week. The test will be next week. I haven't quite figured out what day yet. We only have one more section after this, and that section is a ton of algebra. I'm guessing probably at the earliest next Thursday. That's kind of what I'm thinking. A week from today is kind of where we're at. If it's Friday, it might be Friday. I don't know. In this case here, we've got the machine shop. And if you look at the problem itself, it's talking about time it takes to make all these things, and it talks about profit. So you've got two parts, 1 and 2. It goes through 3 machines, A, B, and C. Okay? Goes through 3 machines, A, B, and C. You've got parts 1 and 2. You know that machine A can't use any more than 120 minutes. Machine B can't use any more than 72 minutes. And machine C can't use any more than 180 minutes. That's just from the problem. You agree so far?
Yes, sir.
All right. Now, it says that each part 1 and part 2, I'm going to use X and Y. Is that okay? For part 1 is X, part 2 is Y? So, for machine A, you have X plus Y. You have that for all of these. But you have specific amounts of time. What do you got? You got it?
I think I got it.
Part A has, what, 4 and 5. This one is 4 and 1, and then 5 and 6. Okay? Bless you. Your goal here was to maximize your profit. The profit one is that you made $8 on part X and $5 on part Y. Air 5.
One thing we got right.
Yeah.
Okay, so, wait, where did you get the 8 and 5?
8 and 5. Right here. The shop makes a profit of $8 on part 1 and $5 on part 2. It's right in the middle.
Yeah, I think that's
It's right in the middle on that one.
I forgot.
Yes, sir.
I had X plus 4Y is less than 72. Does that work or no?
X plus 4Y. As long as the other ones are flipped all the way around, you're okay. And that's where you got to be careful. And I think that's what happened to yours earlier, Daisy. You flipped one of your variables, and that's what switched it around on you. That's why when you write these things out, one of the easier things to do is if you started out as you've got part 1 and part 2, and just label everything straight down in a column. All right. And then you have time. There's one other part to this.
Yeah.
I know. And this is the one where a lot of you guys kind of go, must not be less than half parts of A. So Y can't be less than half of the parts of A. So that means it's got to be greater than or equal to the parts of A, right?
Y is greater than or equal to 1/2 X.
Perfect. Y is greater than or equal to 1/2 X.
How would it be?
Because it says part 2 produced must not be less than half the number of part 1. So it just so happens that X is part 1 and Y is part 2.
You got it. All right. Oh yeah, please. There's a lot of things I can say right now, but I won't. No. So we've got all of our parameters. Oh, can we have negative parts? No. So let's kind of go without saying in this case, x and y are both greater than 0. So now we have 6 things to worry about. This is where things start to get a little bit messy. So when you set this up, you draw a graph. Yes.
And we're done.
X and Y. Now, here's what I'm going to do to help, because I know some of you guys are having issues where things line up, what lines match with what lines. One thing you can do is label each line as you go, or in my case, I can change color. So I'll go black, red, purple, and the last one I'll do is the blue one.
Wait, why isn't there a green?
Because green doesn't show up very clearly. It's very light, so I changed it to purple.
Dirty.
Anyway, so we go through our intercepts for the first one. The first one gives me intercepts of 30 and 24.
Dual squad.
And it's working inward. The next one gives me intercepts of 18 and 72.
Mr. Murphy,
Yes, sir.
is it good to have 2 maximums? Or, like, is that more fortunate?
No, it's just, it happens.
Doesn't that mean that you have 2 different probabilities? that
Yes.
make you match?
And then next one we have 36 and 30. No.
No, sir.
Now, right now, I'm not drawing in the 1/3, or excuse me, the 1/2. What do you got, Shane?
I was gonna ask, what kind of problem would it be where we were not in the first quadrant? Is like something negative, or is it always probably gonna be?
I think everything that you get from here on out should be first quadrant. Word problems are usually first quadrant because you're looking for a tangible value. You're looking to maximize profit. You're never going to have a negative profit.
Is it gonna be all word problems in the test or in the first one?
I might have you graph one of the other ones where you have to find the shaded region where you can graph into a negative region. And that's fine, but the word problems are usually first quadrant. All right. Now, I have not graphed the last line yet because I don't have graph paper. It's kind of difficult to walk up 1 over 2, up 1 over 2 all the way through this. So what I want to do is just pick a spot because as of right now, I've got this intersection and this intersection to worry about. And I want to pick a spot to figure out, is this line going to be below it or above it? And I can do that once I figure out what this value of the ordered pair is. Because I can substitute into here to see if it's above or below the line, so it's true or false. See what I'm saying?
Yes, sir.
So, the intersection of the red and the black was right here. The intersection between these two, or intersection, excuse me. What's the easiest way to solve that system of equations? Linear combinations, subtract them, right? Because I've got 4's on top and bottom. So if I take equation A and equation B and I subtract them, you get 4y is 48, y is 12. Do you agree?
Yes.
Everybody okay with me shortcutting just writing it from the problem? All right. If y is 12, what's the value of x? 12 goes here. 72 minus 12 is?
60.
Divided by 4?
12. Or 15.
Close. 15. So right here, the ordered pair is 15, 12. Okay? Now, 15 and 12 I'm going to use as a test point. Is 12 greater than half of 15? It is. So that means that it's a true statement, which means this line has to be below it because it's going that way. That's the trick to that type of problem. You find one of those intersection points, you use the intersection point as a test point for that fractional one without intercepts, with its intercepts of 0, to find that point right there.
So is that?
Yeah, so now I know that I can solve for this intersection with the blue and the red because y is half of x. Remember, we get rid of the inequality when we do that? So I get 4x plus 1/2 x equal to 72. 4.5x is 72. X is it 18? Or I think it's 16. No. Yes, it's 16.
Got it.
Is it 16? Okay. So that ordered pair is at 16. And what's half of 16? 8. So your points then, because you're bounded in this direction, is right here. That's a tricky problem because you got to worry about that line that doesn't have x and y intercepts that you can quick graph. You got to worry about walking your slope idea. Whenever you have a problem like that, which you'll have one tonight, do that line last. Do that line last, that way you know where it lies within the graph area, above or below some of the other intersections. Okay?
So we gotta find the minimum max.
Yeah, we just gotta find the maximum out. Now you got the ordered pairs, it should be easy. You got 0, 0, 18, 0, 16, 18, 15, 12. There's 5. Oh, I don't mean 18. I'm sorry, I didn't mean, there's only 4 of them. Sorry about that. And 0, 24. You substitute into your maximum one. And the maximum occurs at 15, 12. You get 15 of part 1 and 12 of part 2.
It's not 16. Yeah, shouldn't it?
Oh, 16.8. I wrote 18 by mistake. Sorry. It's 16.8.
That's right.
Sorry about that. I just realized I did that. Because I looked at the 18 on the dot there. My fault. So it should be at 15, 12. You're right. If it was 16, 18, it would be right. You weren't right this time.
Darn.
Neither was I. Aside from this problem, were the other two bearable? Quite bearable? Okay. Today I'm giving you 3 more.
These types in general.
3 more of these
It
types.
took me a full page just to do 2.
So on chapter 3, it's on page 167. I want you to do them in this order: 22, 21, and 23. Yes. These are 3 more word problems. I'm going to kind of give you an idea of how it sets up. Number 22 is the easiest of the 3. Number 21 is just a little bit more difficult because there's a conversion you have to do. How many quarts are in a gallon? 4. That's the conversion you have to know. All right, there are 4 quarts in a gallon. Convert the problem all into quarts. Okay? And then 23 is similar to that last problem we had with the machine because it says that one thing is 3 times another. Plot that line last. Okay? With the other ones, I will help you start with 22.
So you want us to do them in that order?
Yeah, because it's a little bit easier. That way you don't get stuck on the first one and say, screw it. All right? Now, let's take a look at number 22 together. And what I did with last hour also is I kind of helped them create a chart to figure out what's going on. As you read the problem, it says that your office manager is purchasing file cabinets and wants to maximize storage space. What's your objective? Maximize storage space. So your objective is max power. Max storage. You have 60 square feet of floor space and $600 in the budget to purchase them. Right off the bat, 2 parameters. Floor space and money. So you have up to 60 square feet of floor space, and you have up to $600 to spend. Cabinet A uses 3 square feet of floor space and has a storage capacity of 12 feet and costs $75. So we have cabinet A and B for all of this. Now, this one deals with max storage. This is floor space, and this is money. In that sentence, what's the floor space for A?
12.
3. That's the storage capacity. So it has 3 feet here, 12 cubic feet for storage, and it costs $75. What I'm doing is putting them all in order. Where they go. I do the exact same thing with B. Can you finish it? Can you have negative cabinets?
No.
There you go.